action menu, which has many different actions that I can perform to transform this code structure. There are also options in the menu to jump to definition and to view quick help for the text symbol. Since I only want to show the text under a certain condition, I'll click on Make Conditional. And now I can fill in the placeholders again. The condition is if the meditation is active, and now I have another placeholder further down in the file, and I can jump to it using the Control/key binding, which helps me really quickly fill out the missing code without even having to touch the mouse. Now, this is exactly what I want my meditation view to look like. So now I'll switch back to the content view to add it there. I want to add my meditation view to the bottom of this VStack, along with another spacer. And now the preview has updated to show me my welcome title, my play button, and my picker to select a meditation duration. Now that I'm done with the UI, I'm going to close the canvas. And I'll hide the inspector to make some more room in the editor. Close the canvas. And I'll hide the... Now that I'm done with the UI, I'm going to close the canvas. And I'll hide the inspector to make... Now that I'm done with the UI, I'm going to and my picker to select a meditation duration. Now that I'm done with the UI, I'm going to close the canvas. And I'll hide the inspector to make some more room in the editor. Before we try to run our app, I want to modify the meditation controller to make debugging a little easier. And here, I'm going to use the minimap to navigate to the meditation timer state section of code. The minimap shows me text labels for all of the marks throughout this file. And I can navigate to a mark by clicking on the label in the minimap. A mark is a special comment that Xcode understands to show you sections of code in the editor, in the jump bar, and in the minimap. Now, in this section of code, I have several computed properties that indicate state. To make inspecting this state easier, I'm going to add a stored property called state that has one of the possible values stopped, paused, or running. And I'll default this to stopped. Now, when we update the meditation timer, we want to look at the timer's state and update the controller's state using a switch statement. The possible values of the timer state are nil, paused, and running. And in Swift, switch statements must be exhaustive. If they're not, I'll get a compiler error telling me to add the missing cases. And notice that I've gotten a compiler error in my editor without even building my code. These are called live issues, and they appear as you type. So if I click on the live issue, I get a fix it, asking me if I want to add the missing cases. And I do, so I'll go ahead and click on that. Oops. Now, in the case where the timer is nil, I want the state to be stopped. Now, rather than having a catch-all case for all of the possible values that can be wrapped, I want explicit cases for each of those values. So I'll change this underscore to the first value, which is running. And now that I've done that, this switch statement is no longer exhaustive. So I'll get another live issue with another fix-it to add the last remaining case. And I don't need this associated value, so I'll go ahead and remove that. You may have noticed that these two names, running and paused, are the same as the remaining cases of this state enum, and I can use multi-cursor editing to quickly fill out the code placeholders. Right now, I have one insertion point, and I can add another one by holding down Control and Shift and clicking where I want to place my next insertion point. Now that I have multiple insertion points, I can perform any command, and that command will act on each of my insertion points. To see all of the commands that are available, you can go to the Xcode preferences, select the key bindings tab, and here you can see all of the commands and their key bindings, and you can even change the key binding to be whatever you like. So I'll show you a few now. I can select word back, copy, jump to next placeholder, type, and paste. And now we're done. And this is all of the code that we need to implement the basic functionality of our app. Before we dive into running and debugging, let's review what we learned about the source editor. We saw how Xcode's interactive canvas can help us preview the UI of our app and help us edit the appearance of our views. We learned how code completion can greatly speed up the development process. Then we saw how Xcode can help us transform and add functionality to our code structures automatically from the action menu. And finally, we saw how live issues and fixits can help us fix our compiler errors before even building our project. For more information on the new Swift language features that we saw, or the SwiftUI framework that we built, that we used to build up our views, please watch the What's New in Swift and the Introducing SwiftUI session recordings. And now that we're ready to run the app, I'm going to hand it off to Hansa to walk us through running and debugging.
Thanks, Holly. Hi, my name is Hansa, and I'm an Xcode engineer. So now that Prachi created our project and Holly added some code to it, we'll talk about how we can build, run, and debug our app on the simulator and on a real device. And then we'll add a Swift package dependency that allows us to add a new feature to our app. So let's get started. So Prachi has shown you how to build and run our app using the Run button in the toolbar, but we can also do this from the product menu where we have the options to run, test, archive, build, and many more. So right now, I will run the app on the simulator. The app is being built, installed, and launched on the iPhone simulator, and the simulator app comes to the foreground automatically. So this is what our app looks like right now. So because we're moving pretty fast, let's do a quick meditation using our new app. All I have to do is click on the play button to start a new 3-minute meditation. So the meditation started correctly, but the play icon didn't change, which I think is wrong. Just like in music apps, we want to show the play icon when the meditation is paused and the pause icon when the meditation is running. So we'll use the debugger integration in Xcode to help us find and fix this bug. To run our app with the debugger attached to it, I don't need to do anything special, as when I just run my app right now, Xcode automatically attached debugger. So I'll leave the app running in the simulator right now and go back to Xcode. And we'll start looking in the meditation view. We'll get to the meditation view by using the jump bar. And the meditation view is responsible for showing the play icon and the remaining timer label. And here it seems that we're getting the image from the meditation controller's displayed icon property. So to get there, I will command click on displayed icon and select jump to definition. And here we are in the meditation controller. So I will add a breakpoint to the second line of the display icon property getter by clicking on the line number. And because the app is still running in the simulator and the timer is still ticking, the breakpoint got hit right away and highlighted the line in green. Breakpoints in general allow us to pause the app's execution when it hits a specific line of code. So at the bottom of the Xcode window now, let me make this a bit bigger, we have the debug area, at top of which is the debug bar with the buttons to control the debugger, as well as to activate features like the view debugger, the memory graph debugger, and more. Below it, we have the variables view on the left and the console on the right. And finally, on the left-hand side of the Xcode window, we have the debug navigator with information about our running app, like how much work it's doing, how much memory it's using. And below it, we have the call stack. The call stack is the record of how this code is being called. And when I select a different frame in the call stack, Xcode switches the source editor, the debugger, and even the variables down here. So I'll switch back to the original frame, and we'll get back to trying to fix the bug where the icon didn't change after we started the meditation. So let's look at which icon is being used right now. I can do that by selecting the variable and clicking on the quick look icon at the bottom. And here we get a preview. And because the variable that we're previewing is an image, we actually got a rendered version of the image right here in Xcode. Quick Look Previews supports images, colors, views, and even custom objects that implement the debug Quick Look object method. So in the preview, we can see that we're still showing the play icon even though the meditation is already running. So I wonder if it's because the meditation controller is in the wrong state. To find that out, I will expand the self variable, which refers to the meditation controller we're debugging here, and we reveal the properties. And one of them is the state property that is telling us that the meditation controller is in the running state. So that's what I expected. And that means that the displayed icon property getter is not taking the state of the meditation controller into account when picking which icon to show. So to fix that, we will check if the meditation controller is running. And if so, we will show the pause icon. And otherwise, we'll show the play icon. Now, because I don't need the breakpoint anymore, I will remove it by dragging out and letting go. And because we changed the code just now, I will stop the app and click the Run button again. This recompiles the project, reinstalls, and relaunches the app in the simulator. Now, this time, when I start a new meditation, we can see that the icon changed from play to pause. So the bug is fixed. Great. So I'll stop the app for now, and we'll hide the debug area. So we have been running our app on the simulator, which is a great way to quickly iterate on our code. But I would also like to install my app on a real device so that I can start meditating on the go as well. First, to be able to install and run apps on connected devices, we have to sign into Xcode with our Apple ID. We'll do that by going to Xcode Preferences, selecting Accounts, and adding a new account. We'll select the Apple ID, select an account, apps on first to be on device so that I can start meditating on the go as well. First, to be able to install and run apps on connected devices, we have to sign into Xcode with our Apple ID. We'll do that by going to Xcode Preferences, selecting Accounts, and adding a new account. We'll select the Apple ID, type in the username and password, and there, we sign into Xcode with our Apple ID. Next, I'll close the window, and I'll go to the Project Navigator and select the project. Here, we'll select the app target and go to the Signing and Capabilities tab. This is where we manage code signing and capabilities. Capabilities allow us to declare what permissions our app needs. And in our case, we need access to the health kit data to be able to write meditations that the user performed in our app, but also to read meditations that the user performed in other apps so that we can show them statistics for all of their mindfulness activity. So we'll add a new capability, search for health, and select the health kit capability. Next, I have this iPhone connected to my Mac here. So I will select that as the run destination, and I will click Run. Now the app is being built for the device, installed, and launched there. And so that you can watch what's going on the screen, I will use QuickTime Player, which allows me to stream the iPhone screen back to the Mac. So there, we have mine running on a real iPhone now, and I could just unplug this phone and start meditating on the go. Now, let me stop the app and switch the destination back to the simulator. When you want to find out more about devices, you can go to Window, Devices, and Simulators, where we can see the name, the type, and the OS version of the device, as well as we can see the installed apps that we've put there. But also, we could actually configure the device to connect to the Mac over Wi-Fi. And that way, I wouldn't need to physically plug in the phone to the Mac over USB at all, and I would still be able to build, run, and debug on it. So now that we successfully run our app both on the simulator and on a device, and we even fixed a bug in it using the debugger, let's talk about adding more functionality to our app. I'd like our app to show the user statistics about their meditations, like how many they've performed, what the average duration was, and so on. But calculating statistics is not a specific problem to just our meditation app. So we have created a Swift package called QuickStats that solves that problem for us. A Swift package is basically a folder with a manifest file and source files that you can use to build products like our QuickStats library. To add the package to our project, I will go to the project editor and select Swift packages at the top. Here, I will add a new package to our project. And because Prachi signed us into GitHub with our account, we can actually see all the repositories that our account has favorited. QuickStats is right here at the top, so I'll select it. Click Next. We'll use version 1, that looks good. And this is where we make sure that the QuickStats library gets linked with our app. I'll click Finish. And now Xcode manages the fetching of the package in the background. And in the project navigator, there's a Swift package dependency section where I can actually browse the sources of the package, which is a great way to understand how the package works under the hood. Now, before I hand it back over to Holly to integrate this package into our project, let's do a quick recap. We saw how we can run and debug our app on the simulator, and we also ran our app on a real device. And then we added a Swift package dependency to our project that allows us to add a new feature to our app. These are the sessions relevant to the topics discussed in this demo. And next, please welcome Holly back. Thank you.
Thanks, Hansa. During this demo, we will see how to use the QuickStats package in our project. After that, we will walk through how to restructure our project by moving our model code into a framework. Let's head back to Xcode to get started. Now that we've added the QuickStats package, we can import the package into our code and start using its public APIs. As Hansa mentioned, we want to show our users some statistics about their meditation sessions in the content view. We'll jump back to the content view.swift using Open Quickly, which you can find under the File menu. In Open Quickly, I can enter any type name, method name, or file name to navigate to. So I'll type content view and press Enter. The first thing that I need to do is import QuickStats. Now we're ready to start using the APIs from this package. I'm going to add some code below the content view from a code snippet that implements a statistics view that takes in an array of meditation sessions and displays statistics about those sessions using QuickStats APIs. Since I have access to all of the package source code, I can jump to the source code implementation to understand how it works. So if I command-click on quickstats.average duration and select Jump to Definition, I'm now looking at the actual implementation of this method. I can see where the file is in the Project Navigator by clicking on Navigate, Reveal in Project Navigator. And now we can see that we're in the package source code. I can navigate back to the previous file by using the Editor History button in the jump bar. Now let's add the statistics view to the content view. But before we do that, I want to show the canvas. And I'll zoom out so we can see the full device. I'll add the statistics view below the spacer. And it takes in an array of sessions which we can get from the meditation controller. Now we can see the statistics view at the bottom of our content view. And now that I'm done with the UI, I'll close the canvas again. Now we want to start writing unit tests for our model. And to make this easier, we are going to move our model code into a unit testable framework. I could choose to use a Swift package, but I only want to share this code with my team, so I'm going to choose a framework instead. We need to create a new target, and I can use the filter bar to search for framework. And I'm going to call this framework MindKit. I want to make sure to check the box to include unit tests so that a unit test target is automatically created when I create the framework. Now, before I move the code over, I want to import MindKit into all of the files that I know will need it. I know I'm going to move over healthstore.swift, and this file has 2 public types that are used throughout the project. And I'm going to use the Find Navigator to figure out where these types are used. I'll switch to the Find Navigator. And the Find Navigator allows me to search my entire project for text, symbol references, regular expressions, and more. Right now, I want a regular expression. And I want to search for health session or health store. And I'll press enter to see the results. I know that I'm going to be moving healthstore.swift and healthstorefactory.swift into the MindKit framework, and I can hide these results by clicking on the disclosure triangle. Now I'll navigate to each of these files and add the import. So I'll jump to the top of the file here, add the import, and then finally we need it in contentview.swift. Now we're ready to move the files over, so I'll switch back to the project navigator. As I mentioned, I want to move over healthstore.swift, but I also want to move over healthstorefactory.swift. I can select multiple files in the project navigator by holding down Command and clicking on the other files that I want to select. Then I can drag these selected files into the MindKit group. When I do this, Xcode automatically updates the target membership for these files. And we can verify this by showing the inspector and seeing that the target membership for the file open in the editor, which is healthstore.swift, is now the MindKit framework target rather than the Mind app target. Now, I haven't forgotten that we still need to implement the health store that interacts with HealthKit. We're going to do that now so that we can start integrating real health data into our app. The first thing that I need to do is import HealthKit. Now, I've never used HealthKit before, so to get started, I want to read the documentation. I can do this right in Xcode by opening the developer documentation window, which you can find in the Help menu. Here, you can search for a framework from the SDK, a specific API, or a programming topic, such as requesting access to health data. So here I'll search for HealthKit. And now I have access to all of the documentation for the entire framework, and this is also available offline. Luckily, I have all of the code that I need ready in a code snippet, and I'll add that at the end of the file. Now, before we start writing unit tests, I want to add my own documentation for the APIs in the MindKit framework, starting with the health store protocol. I can do this using special comments called .comments. Xcode knows how to generate a .comment template for declarations, and this feature is available through the Action menu. So I'll command-click on the first API that I want to document, which is request access. And then I'll select Add Documentation. Now Xcode has inserted a .comment template with placeholders for the method description, as well as a description of the parameter that it takes in. So this method requests permission from the user to access mindful sessions. And the completion parameter is a closure to execute when the request is done. Now, I know that this method can execute asynchronously, and I want to add a special note that to document that. And I can do that using a special bullet point. And now I can add that note. Now that I have written the documentation, I can view this in Quick Help. Again, we can bring up the Quick Help popover by option clicking on the symbol that we want to view documentation for. And now we can see the description that we just wrote, the note that we wrote, as well as the description of the parameter. And this is available at any call site of request access. For more information on writing and documenting your own APIs, please see the Swift API Design Guidelines, which is available on swift.org. During this demo, we covered how to use and navigate code from a Swift package. We talked about creating a new framework target in our project and moving existing code over into that framework. Next, we looked at the Xcode developer documentation window. And finally, we learned how to write our own documentation through dot comments. Now, I'll hand it back over to Hansa to talk about testing and distribution.
Now, in this section, we'll talk about how we can test our code in Xcode and how to distribute our app once we're ready to ship. Now, since our app is coming along pretty nicely, we need to make sure that it continues to work properly. A great way to increase our confidence in the app's quality is by using automated tests. There are two high-level categories of tests that we will write for our app: unit and UI tests. Unit tests ensure that a single component, such as our health store, works properly by giving it a specific input and verifying that the output matches our expectations. UI tests, on the other hand, ensure that all these components are integrated correctly and that the app works from the user's perspective. So correctly, unit tests ensure that a single component, unit tests ensure that a single and UI tests. Unit tests ensure that a single component, such as our health store, works properly by giving it a specific input and verifying that the output matches our expectations. UI tests, on the other hand, ensure that all these components are integrated correctly and that the app works from the user's perspective. So let's dive back into Xcode. So Holly already created the unit test target for the MindKit framework called MindKit tests, but we'll still need to add it into our test plan. A test plan is a file in our repository that describes how our tests are built and run. A way to see which test plan our scheme is using is to click on the scheme and select Edit Scheme. We'll switch to the test action. And here we can see all the test plans used by our scheme. There's only one, and that's the default. So we'll jump to it by clicking on the jump arrow next to the test plan's name. The test plan editor shows us which test targets it's using. And we already have the UI test target here, for which we'll write code in a minute. But we'll still need to add the unit test target. We'll do that by clicking on the plus button at the bottom and selecting MindKit tests. Now let's actually write our unit test code. I will write some unit tests for our health store. So what I'll do now is Control-click on the MindKit tests group and select New File. I will use the unit test file template, and we'll name the file test health store. That looks good. The first thing we'll do here is import MindKit, because that is where the code lives now. And to be able to test not only public, but also internal interfaces of the MindKit framework, we'll add the testable keyword to the import. Next, I'll add 2 tests to our class. The first one verifies that after we've saved a meditation, we can retrieve it right back. And the second one ensures that we can actually request access to read and write data. So I'll run these tests by going to product test. Now these tests are being built for the simulator and run on the iPhone XR simulator. Now that the tests have finished, we can actually see next to the test name in the source editor test diamond that both of them succeeded. Good. Now we can also see the test hierarchy in the test navigator. So we added a few unit tests for our health store, but we want to make sure that the UI of our app works as well. So we'll add some code to our UI test. I'll jump to the existing MindUI test class by selecting it in the test navigator. And here we will add UI test code that launches our app, starts a new meditation. A few seconds later, it pauses the meditation. And then finally, it verifies that the remaining time label shows what we expect. So I'll run our tests again. And this time, I'll bring the simulator to the foreground so that we can watch the UI test run. So the app is launched, a new meditation is started, and a few seconds later, it gets paused and the app gets terminated. Next, we can also see the unit test launch the app for a moment. Now, it seems that some of our tests failed, and to figure out what exactly happened, we'll go to the report navigator by clicking on the rightmost navigator button. Here, I'll select the top, which is the most recent test action, and we get to the test report. Here, I can see that the new UI test I just added is marked in red, which means that it failed. And to know what exactly happened, I will disclose the test and drill into the failing activities to see that the assertion failure says that 0,256 is not equal to 256. Now, this is starting to make sense. But to really understand what was on screen when the failure occurred, I can disclose the failure itself to reveal an automatic screenshot, which I can preview with the quick look icon. And here I can clearly see that the remaining timer label shows 0,256, but our test assertion at 256. So I'll close the preview, and we'll jump back to the test source by clicking on the jump arrow next to the test's name. And here, we'll fix the assertion by adding the leading 0. Now, I'll rerun just this one test by clicking on the test diamond next to the test name. And again, we can see the app being launched. A new meditation starts. A few seconds later, gets paused. The app gets executed, and this time, terminated, sorry. And this time, we can actually see with the test diamond that the test succeeded. That's great. Finally, now that we have a functional app, we would like to make it available to more people. To build an app for distribution on the App Store or TestFlight, which is Apple's beta testing service, we need to perform an archive. To do that, we first select the generic iOS device run destination, and then select Product Archive. And this builds the app in the release configuration and produces an archive that we can use to distribute our app. When it finishes, it opens the organizer automatically. And here, when we select the archive, we can click Distribute App. And we would go through this flow to submit our app directly to Apple from Xcode. Please note that to deploy apps to TestFlight or the App Store, you'll need a registered developer account associated with your Apple ID. Once your app has been uploaded, you can manage it using the App Store Connect website. And this way, you can ask your friends and family or your colleagues to download your app using TestFlight and eventually get it listed on the App Store as well. So in this demo, we started by creating unit and UI tests for our app. And then we learned how to edit our test plan and how to use the test report to diagnose a test failure. Then we built an archive and discussed how to use the organizer to upload our app to TestFlight or the App Store. To learn more about these topics, please refer to these talks. And now let's recap what we saw in the last hour. Today, we went through the whole journey of creating an app from scratch. Prachi created our project and introduced the Xcode UI. Then Holly added code to our app using the source editor features to make that process really smooth and fun. Then I came up to discuss running and debugging on the simulator and device, and we added a Swift package to our project. Then Holly came up and integrated the Swift package and split some of our code into a framework. And finally, we just learned how to use the testing integration in Xcode and how to distribute our app to the App Store or TestFlight. For more information about the session, please refer to this link. And if you have any questions, there's a lab starting right after this session ends. And have a great week. Thank you very much.